35 metres long, 14 metres wide, 11 metres tall. The height of a 3-and-a-half-storey building, rolling across the countryside on 6 separate track assemblies. The Landkreuzer P.1000 Ratte, proposed by Krupp engineer Edward Grotte in June 1942, was designed to weigh 1,000 metric tons. Place its silhouette against a Tiger I, and the Tiger vanishes beneath it. 18 times lighter, nearly 4 times lower, more than 5 times shorter. Now place the Ratte against a football pitch. Its footprint fills nearly a third of the playing surface. Now place it against the German battleship Bismarck, 251 metres long, 36 metres across the beam, 50,300 tons fully loaded. And the comparison stops being absurd. It becomes the entire point. Because the Ratte didn't just resemble a warship, it carried a warship's guns. Specifically, the dual 28-centimetre SKC/34 naval turret salvaged from the damaged Gneisenau, the same type fitted to the Scharnhorst-class battlecruisers. Bismarck on tracks. That's what Krupp proposed to build. And by 1942, Allied air power had already demonstrated, with decisive and documented violence, exactly what happened to Bismarck. Air power made super-heavy armour obsolete before the Ratte's blueprints were dry. The bigger the target, the easier the kill. Every specification in the Ratte's design file proves it. Start with the hull. Front armour was planned at 250 millimetres of hardened steel, well angled at the glacis. Formidable by any standard, thicker than most bunker facings, enough to shrug off virtually any tank gun the Allies fielded. But armour is only as strong as its weakest face. The Ratte's weakest face was the one aimed squarely at the sky. That vast roof, hundreds of square metres of engine deck, turret top and hull ceiling, was necessarily the thinnest surface. You can't clad every face of a 1,000-tonne vehicle in 250 millimetres of hardened plate without pushing the mass into territory that makes even fantasy engineering flinch. One analyst described this enormous horizontal expanse as a prime target from above. Above is precisely where the Hawker Typhoon spent its working day. Beneath all that steel sat the proposed power plant. Engines consuming fuel measured in thousands of litres per operational hour, inside a nation that was already desperately rationing every drop of fuel it had. And here was Krupp, proposing to add a vehicle to the logistics chain that consumed fuel like a small destroyer flotilla. Theoretical top speed was 40 kilometres per hour. Theoretical is doing extraordinary work in that sentence. The Panzer VIII Maus, the heaviest, fully enclosed armoured fighting vehicle ever actually constructed, weighing 188 tons, managed 13 kilometres per hour under the strain of a Daimler-Benz aircraft engine. 13 kilometres per hour. A brisk walking pace for a fit soldier. Multiply the Maus's weight by 5.3, and that optimistic 40 kilometres per hour for the Ratte begins to dissolve into engineering fiction. The power-to-weight ratio alone suggests the Ratte would have crawled rather than rolled, dragging its 1,000 tons across terrain at speeds that would make horse-drawn artillery look sprightly. Secondary armament included flak guns mounted on the hull. A crew of 20 or more would have operated inside the vehicle's compartments, and the whole assembly, guns, engines, crew, fuel, ammunition, couldn't cross a single military bridge in the European theatre. The Bailey Bridge, the backbone of Allied field engineering, was rated for 60 to 70 tons under optimal conditions. The Ratte weighed more than 14 fully loaded Tiger I tanks standing on the same spot. Rail transport was physically impossible. The vehicle was too wide for any existing gauge, too heavy for any rolling stock ever manufactured. River crossings meant fording, And fording at 1,000 tons in the soft-bottomed valleys of northern France or the Low Countries meant sinking into the riverbed and staying there. Roads would crumble beneath those 6 track assemblies, each 1.2 metres wide and 21 metres long, leaving a trail of destroyed infrastructure marking every metre of the Ratte's advance. Before a single Allied aircraft ever lifted off to find it, the Ratte had already defeated itself. A vehicle that destroyed its own lines of advance simply by moving forward was less a weapon and more an elaborate form of self-sabotage. The Mouse proved this at 1/5 scale. 2 prototypes were built, tested, and found wanting. 188 tons, 13 kilometres per hour. Too heavy for any bridge in the Wehrmacht's engineering inventory. Too slow to keep pace with any combat formation. Too thirsty for fuel the Reich couldn't spare. Advancing Soviet forces eventually captured both prototypes, but the Germans already had the empirical evidence in hand. And every problem exposed at 188 tons, the collapsed roads, the impossible bridges, the glacial speed, the insatiable fuel demands, would have been amplified by a factor of 5.3 at the Ratte's 1,000 tons. The Germans proposed to ignore it at 5 times the scale. Alongside the Ratte, the P-1500 monster demonstrated just how far the escalation went. 1,800 tons, 25 metres long, armed with the 800mm barrel of the Schwere Gustav railway gun, the largest artillery piece ever fired in combat, mounted on a self-propelled chassis. If the Ratte was Bismarck on tracks, the monster was an entire naval dockyard compressed into a single vehicle. Together, these projects mark the outer boundary of what happens when an arms procurement system rewards ambition over analysis, and when the person making the final decision prefers spectacle to survivability. Somebody within that system still recognized the absurdity. Albert Speer, Hitler's armaments minister, reviewed the Ratte proposal in early 1943. He cancelled it. Inside a procurement culture where firms like Krupp, Porsche and Henschel competed for Hitler's personal favour by proposing ever larger, ever more theatrical weapons, where Hitler's documented obsession with gigantism and decisive wonder weapons warped every level of military acquisition, Speer looked at the specifications and killed the project. The fact that the proposal reached his desk tells you everything about the culture. The fact that he cancelled it tells you that some fragment of engineering pragmatism still survived behind the curtain. Speer wasn't known for his moral courage. He couldn't say no to genocide. But he could say no to this. His cancellation denied the Allies a gift they didn't know they'd been offered. Here is the weapon he kept out of their hands. The RP-3, rocket projectile 3-inch, carried a 60-pound warhead in either high explosive or semi-armour-piercing configuration, riding a solid fuel motor fired from under the wing at dive angles between 30 and 45 degrees. RAF records document the Hawker Typhoon's standard ground attack loadout as 8 of these rockets, 4 under each wing, plus 4 20mm Hispano Mark II cannon. One Typhoon carried 480 pounds of rocket warhead into a single diving pass. A flight of 4 carried nearly a ton. A full squadron sortie put 12 to 16 aircraft overhead, delivering 96 to 128 rockets in a matter of minutes. By 1944, the standard RAF tactical air response operated on the cab rank system. Typhoon flights orbited at altitude, waiting for ground controllers to vector them onto targets. Response time from request to rockets on target was measured in minutes. The cost of those 32 rockets, measured against the steel, engineering hours and strategic materials consumed by a single P.1000 Ratte, represented perhaps the most lopsided exchange ratio in the history of military procurement. Like buying a castle and watching someone flatten it with a bag of gravel. Post-battle operational research from Normandy forced a reckoning with rocket accuracy. In one rigorous study, investigators examined 294 Typhoon ground attack missions. Pilots fired 2,088 RP-3 rockets at armoured targets. Researchers went to the attack zones, examined 43 tanks found there, and confirmed 7 rocket hits. 7. 1 hit per roughly 300 rockets fired. The wartime propaganda image of surgical rocket strikes dissolved under statistical scrutiny. Typhoon pilots were diving at 400 miles per hour, firing unguided projectiles at small, well-camouflaged, fast-moving rectangles through a 2-second firing window. And they were missing far more often than they connected. This finding embarrassed the RAF. It delighted skeptics. And it's the single most important piece of evidence in the Ratte's death warrant. The reason that hit rate was so dismal against standard tanks is target geometry. A Tiger I presents a compact shape, roughly 6.3 meters long, 3 meters tall, 3.56 meters wide, often concealed by hedgerows, buildings, or camouflage netting. From 2,000 feet at 400 miles per hour in a 30-degree dive, that's a flickering rectangle that disappears behind a tree line in a heartbeat. The Ratte measured 35 meters long, 14 meters wide, and 11 meters tall. Roughly 30 times the cross-section of a tiger viewed from above. Hedgerows couldn't conceal something taller than the trees flanking the road. Camouflage netting in those dimensions didn't exist in any army's inventory. The nearest village street was almost certainly narrower than the Ratte's 14-metre hull. A circle of probable error that would place a rocket 5 metres from a Tiger's centre of mass still landed on the Ratte's hull. From a diving Typhoon's perspective, the worst accuracy problem in tactical aviation simply ceased to exist. The vehicle was its own kill zone, and the RP-3's 60-pound semi-armour-piercing warhead didn't need to punch neat holes. Documentation from combat assessments showed these warheads capable of ripping turrets entirely off standard German tanks, not penetrating them cleanly, but tearing them from their turret rings through raw kinetic violence. Against the Ratte's roof, the thinnest armour surface, struck at the optimal angle by a diving aircraft, those same warheads would crack welds, jam the turret ring, destroy external optics and range-finding equipment, sever radio antennae, shatter the ventilation systems needed to keep 20-plus crewmen alive inside a 1,000-ton steel oven. High explosive warheads striking the running gear, those 6 track assemblies, each 21 meters of exposed, practically unarmorable track links and road wheels, would shred mobility components and freeze the Ratte in place. An immobilized Ratte had 0 options. Retreat was impossible. Repositioning was impossible. The vehicle would sit, burning fuel, while the next cab-rank flight lined up. Against a Tiger, a pilot had perhaps a 2-second window to fire accurately during a diving pass. Against the Ratte, that window stretched to 5 or 6 seconds, an eternity in ground attack aviation. Enough time to walk rockets across the entire length of the vehicle and observe impacts before pulling up. 2 squadron sorties, roughly 250 rockets, delivered over 30 to 45 minutes, would have saturated the Ratte with enough kinetic energy to blind it, immobilize it, and set it burning, even if no single warhead breached the primary hull armour. The Typhoon didn't need to penetrate the Ratte. It needed to strip away everything that made the Rat functional. RP-3 rockets accomplished that against targets a fraction of the size. Suppose the Rat's designers had somehow solved the roof armour problem, thickened every surface to match the glacis at 250 millimetres, accepted the ruinous weight penalty, and still produced a vehicle that moved. RAF 617 Squadron had an answer for that too. The 12,000-pound Tallboy, one of Barnes-Wallis's earthquake bombs, designed to punch through 16 feet of reinforced concrete before detonating, proved its credentials in November 1944. Target? The battleship Tirpitz, Bismarck's sister ship, anchored in a Norwegian fjord. 42,000 tons of battleship armour. Tallboy strikes and near misses buckled her hull through ground-transmitted shockwaves and capsized her. The weapon designed to punch through 16 feet of reinforced concrete killed a capital ship. A 10-ton weapon falling at near supersonic velocity, designed to penetrate deep into the earth before detonating, creating a localized seismic event that shattered structures from beneath. The 22,000-pound Grand Slam escalated further. Against the Rat. Resting on soft ground, its 1,000 tons distributed across 6 track assemblies that transmitted every vibration directly into the hull structure. A Grand Slam near miss wouldn't need to touch the armour. Ground shock alone would shatter track links, crack hull welds, rupture fuel lines, collapse internal compartments, and potentially bury the vehicle in its own crater. A direct hit would be redundant. Bomber Command's carpet bombing patterns were notoriously imprecise against point targets. A bridge might survive dozens of sorties because bombs fell in spreads hundreds of metres wide. The Rat turned that imprecision into an advantage for the attacker. 35 metres long, 14 metres wide, moving at speeds that generous estimates placed at 40 kilometres per hour across terrain it was actively destroying. A Lancaster dropping a standard bomb load in a stick across the Rat's predicted path would crater the ground so thoroughly the vehicle drove into its own grave. The weapon that killed Tirpitz, Bismarck's sister, would kill Bismarck on tracks with identical physics, applied to a target possessing a fraction of a warship's structural integrity. The third kill method strips away the glamour entirely. No Typhoons, no Lancasters. A fabric-covered Auster observation aircraft, barely more sophisticated than the swordfish biplanes that crippled the actual Bismarck in May 1941, carried nothing but a radio and a pair of binoculars. That was sufficient. Allied artillery doctrine by 1944 had refined massed fire into a lethal science. A divisional artillery concentration brought 24 to 36 guns of 105mm calibre onto a single observed target within minutes of a fire mission request. Corps-level assets added 155mm howitzers, 8-inch guns and 240mm heavy howitzers, purpose-built to crack fortified positions. Sustained fire from a full corps artillery group onto a near-stationary target the Rat's size would obliterate every external system through cumulative effect alone. Dozens of heavy-caliber shells detonating on and around the hull would incapacitate the crew through armour spalling, concussive shock and carbon monoxide accumulation long before the plate itself was breached. A Tiger under artillery fire could reverse behind a ridgeline or slip into a tree line. The Rat was taller than most buildings and wider than most roads. An artillery spotter in a grasshopper circling at 3,000 feet could track it from tens of kilometres away and adjust fire with unhurried precision, correcting each salvo closer until the shells walked directly onto the hull roof. Near any coastline and any Atlantic wall defence scenario inevitably placed the Rat near one, Allied naval gunfire support included battleships firing 14-inch and 16-inch shells, the same caliber of ordnance that destroyed warships in fleet engagements. A broadside from USS Texas or HMS Warspite, directed by that same spotter aircraft, would close the loop with brutal symmetry. The vehicle carrying a warship's guns destroyed by warship guns fired from actual warships. Bismarck on tracks, killed by the weapons that killed Bismarck's peers. These kill scenarios aren't theoretical constructions. Each rests on documented combat outcomes. The post-battle operational research from Normandy confirmed what the accuracy statistics already implied. Hitting small, well-camouflaged, fast-moving armoured targets from a diving aircraft was extraordinarily difficult. But every factor that protected conventional armour from air attack, compact profiles, concealment behind hedgerows and buildings, the ability to disperse and reposition rapidly, was physically impossible for a vehicle standing 11 metres tall, stretching 35 metres long, that cratered roads behind it and couldn't cross bridges ahead of it. Allied tactical reconnaissance aircraft would have identified the Ratte within hours of it moving. If not from its physical profile, then from the trail of destroyed infrastructure marking its path like a scar across the landscape. Germany's resources were finite and shrinking. Every ton of steel shaped into Ratte armour plate was a ton unavailable for Panzer IV hulls, Stug 3 casings, or Messerschmitt airframes. Every specialized component consumed by the Ratte was denied to the U-boats, fighters, and anti-aircraft guns that Germany desperately needed. Every engineering hour Krupp spent on blueprints for a 1,000-ton fantasy was an hour not spent solving the real production bottlenecks throttling Germany's conventional armour output. The opportunity cost wasn't abstract. Tiger I production consumed resources at rates that already strained German industry. A single Ratte would have devoured materials equivalent to dozens of proven combat vehicles. Those resources, redirected toward fighters or interceptors, might have contested Allied air superiority, the very condition that made the Ratte suicidal to deploy. Instead, the proposal asked Germany to build air power's ideal target using resources that could have built air power's only credible counter. Production trade-offs haunted German armour throughout the war. The Panzer IV was mechanically reliable, logistically manageable, and its 75mm L-48 gun proved effective against Allied medium armour at standard combat ranges. Stug 3 assault guns, cheap, low-profile and effective, were responsible for more Allied tank kills than any other German armoured vehicle type during the war. Advocates for mass production argued that more hulls across more fronts, supported by a functional supply chain, would have delivered greater aggregate combat power than fewer, heavier, more complex vehicles. The counter-argument carried weight too. By 1944, the Panzer IV's armour couldn't withstand hits from T-34/85s or IS-2 heavy tanks on the Eastern Front. And feeding more thin-skinned vehicles into engagements against superior opponents merely accelerated crew losses without shifting outcomes. A truncated US Army logistics study on German armour production, frequently cited in these arguments, framed the core tension, and competent assessors landed firmly on both sides. The tension between quantity and quality in German armour procurement remains genuinely unresolved, an honest debate, not a settled one. What is settled is the fate of super-heavy platforms when exposed to concentrated air power. History delivered that verdict on the 7th of April 1945. The Japanese battleship Yamato displaced over 72,000 tons fully loaded, 72 times the proposed weight of the Ratte. Imperial Japanese Navy specifications show she carried the thickest armour ever fitted to a warship. A main belt of 410 millimetres of hardened steel, angled at 20 degrees, with a deck armour scheme designed specifically to resist plunging shell fire and aerial bombs. Her anti-aircraft suite by 1945 numbered well over 100 guns of various calibers, from 127mm dual-purpose mounts down to massed 25mm automatic weapons firing curtains of steel into the sky. She could manoeuvre at 27 knots across open ocean. She had the entire Pacific to hide in. 386 aircraft from Task Force 58 found her during Operation Tengo. Between 11 and 13 torpedoes struck her hull. At least 6 bombs hit her. Within 2 hours of the first hit, 72,000 tons of the most powerful warship ever constructed rolled over and sank. Yamato carried armour the Rat couldn't match. Anti-aircraft defences the Rat couldn't approximate. Speed and manoeuvrability that made the Rat look welded to the ground. Sophisticated fire control systems, supplied by deep magazines, operated by thousands of trained sailors. And aircraft killed her in a single afternoon. The Rat weighed 1/72 of Yamato's displacement. It couldn't manoeuvre, it couldn't hide. It had no escort screen, no coordinated anti-aircraft defense network, no ability to absorb multiple torpedo-equivalent impacts across watertight compartments. Yamato's sinking didn't suggest the Rat was vulnerable. It proved a question was already answered, definitively, before anyone needed to ask it. The P.1000 Ratte was a super target. 1,000 tons of steel, fuel, and institutional dysfunction shaped into the largest bullseye in military history, proposed by engineers who couldn't refuse a system that rewarded fantasy and punished candour. Speer killed it on paper in early 1943. The RAF would have killed it in the field in an afternoon. With rockets, with bombs, or with a bloke in a canvas aeroplane and a radio. And somewhere in an alternate timeline where Germany actually built the thing, Typhoon pilots are still buying rounds to toast the man who green-lit it. Subscribe for more stories like this.